So 68 and 5.1 is actually a cool question from a like interpret this kind of thing standpoint. So I have 400 e to the 0.1x equals 500 e to the 0.8x. And I want you to think about this in terms of a population model for a second. So if the left-hand side, that 400 e to the 0.1x was a population model, what is that thing?
Population of that 400 grows.
That's a decrease.
No, that's an increase of 10%.
Yeah, so this thing is a population that starts at 400 and compounds continuously at 10%. You guys see that?
1x.
0.1x,
Oh,
right?
one.
And this guy is a population that starts at 500 and compounds continuously at
0.08%.
8%. You guys see that? So this one starts lower but compounds faster, and this one starts higher but compounds slower. So I expect these to meet, right? You guys see that?
Oh,
Okay. So I think I should what? Both sides.
Natural log both sides.
Natural log both sides. You could divide the 400 or the 500 one way or the other. It's not going to make much difference. I would divide by 100 first,
Just to make it easier.
just to make the numbers smaller. But whatever. I'm going to do this one my way because I can. So I'm going to multiply by 1 over 100, and I'm going to rewrite this thing as 4 e to the 0.1x equals 5 e to the 0.08x. And really all I'm doing is I changed my population units from one individual in the population to counting hundreds of individuals.
Is that like 100 to 1 ratio?
Yeah, exactly. Yeah, I just relabeled the units, right? So instead of counting one person, I'm now counting hundreds of people. Who cares?
sweet.
Naturally, we was natural log.
So then naturally we should natural log both sides. So we'll get natural log of 4 e to the 0.1x is natural log of 5 e to the 0.08x. And then what?
Log rules split apart.
Log rules. So that'll leave me with log of 4 plus
0.1x.
0.1x is log of 5 plus
0.08x.
0.08x.
Wouldn't it be log of 0.1x?
Be log of, so this guy here is natural log of e to the 0.1x.
Okay.
And then the log and e are inverse functions, so you get a 0.1x out of it.
And your answer's pretty much there. You just have to do some
Yeah,
small-
so then I gotta fiddle about a little bit. So I'm going to, what? Subtract 0.08x
Come on.
and subtract log 4 from both sides. So I will get 0.02 x's equals
Log of 4 minus log. Or log of 5 minus log of 4.
log of 5 minus log of 4. Again, these guys get stuck together or not?
No.
Not. Those are not like terms. Do not stick them together. The only way you could stick them together is with the division log rule. So you could
Would you make it easier in your calculator?
make it into log of 5 divided by 4. Right, which might make it easier to stick in your calculator, but I don't care. So then what? What's your last step? Divide by 0.02. So multiply by 1 over 0.02. So you get x is log of 5 minus log of 4 over 0.02. Boom. Check done.
So if you were given like a real world application, you'd solve that and then multiply it by 100, let's get back to units.
I don't need to get back to the units. So what I changed was the way I was counting populations, right? The output unit. This is the thing about the input units. So this is a time. Can somebody give me a calculator approximation for this quick? What? So
I don't understand why the 0.1x doesn't get natural log because it was included in the parentheses of the what's being natural log.
Yeah, so I was natural logging e to the 0.1x, right? And the natural log asks, what's the power on e for this stuff in here? The power on e there is just the 0.1x. Another thought you could do, right, is you could drag that thing down using log roll and then know that the natural log of e is 1. Either way, I don't care what approach you take. What did you get for an answer?
11.1571777.
Okay, so we got x is approximately 11. What does that mean?
Are we in, what is our time usage?
This thing?
Years?
It's a squiggly equal
It's
sign.
approximate.
No, it's not, no. Is that better? Okay, so x is approximately 11, which means what?
It's 11 time units of whatever.
Yeah, this is 11 time units before the smaller population catches the bigger one. You guys see that? Cool.
Cool.
So, in a like maybe money thing, right? This would be, you can put less money into a higher interest account than you can into a lower interest account. This is how long it takes for those two accounts to have the same amount of money. You guys cool with that? So if you're not going to keep it in for 11 time units, then you should go with the bigger one. Cool?
Why wouldn't you just put more money into the higher interest? So-
Fees. I don't know.